So here we're going to have a look at 1998, question 3, part A. So a football is kicked on level ground, certain speed, an unknown angle, and strikes a vertical wall. Well, let's do a quick little diagram of this and see what we're looking at here. So there is our ground. There's our vertical wall. Now the football is kicked from here and it's 4 meters away. And 2 meters high to this point. All right. We're told it goes off with angle. We're not told the angle, so we're going to call it angle alpha. There it goes. And hits this. So let's think of what this actually could look like in reality. So either it goes up, 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 and down, or it goes up and hits that. Okay, option 1, option 2, and actually there's two different, you can see here straight away there's two different solutions for alpha. All right, now in this question, what we're going to do is we're going to find the time. We're not going to be able to find an actual number for the time. Instead, we're going to find an expression for that, and subbing it in, we're going to solve it. So let's begin to lay this out. Well, first of all, we know it's going to travel 4 meters in the x direction and 2 meters in the y direction. So we can deal with each of these separately. In the x direction, the speed here is going to be ui, and that is our speed here, and we're given this in the question, which is the square root of hg by cos alpha. All right. Now, if we go back to our little equation here, s equals ut plus a half at squared. This is a very nice one because, of course, we have no acceleration in the x direction. So this becomes s equals ut. In this case, it is 4 equals u. Well, that's the square root of hg cos alpha by t. All right. Looks a little bit ugly. We'll just do a little bit of rearranging here. So we know that t equals 4 all over square root of hg cos alpha. I'm going to leave all these as square roots and g's. I'm not going to multiply any of these out in numbers because if I'm lucky later on, stuff will start cancelling out. Okay, let's go to the y direction. Y direction, of course. Now, doing exactly the same thing here, we know that uj, which are y component, is going to be simply root hg sine alpha. All right, using our same equation as before, s equals ut plus a half at squared. It's not going to be as tidy this time because we do have acceleration. We are going to know that 2, which is our distance, is root hg sine alpha t. Okay, now what we're going to watch out here, we're going to watch our signs because it's minus g over 2. Okay, it's a half minus g and t squared. Okay, so now sometimes what you can do is you can equate these two equations. In this case, looking at it, it's going to be much easier to sub it in. So that's the way I'm going to go on this one here. So we'll just kind of come up to the top here and we'll sub in t. And that t is going in there. It's going to get ugly before it gets good. So 2 now already you can see there's some cancellations going to go on here. So this is going to be a bit of a messy line, but it's going to get better after this. Minus g over 2 by 4 all to be squared. I'm not going to try and square that out in all one go. We'll do the next step just so we don't make small slips. So let's see what we can start to tidy up. looking at this here straight away, root AG, gone. So that one is going to get prettier. So we have 2 equals 4 sine alpha over cos alpha. Okay, minus g over 2. Let's multiply this all out. That's going to be 16 all over hg cos squared alpha. Make sure you know how to do your squares. If we have cos alpha all to be squared, we'll write it in like this with the square sign in there. Okay, tidying up time. Now what I'm going to do is I'm going to pull the numbers out and I'm going to leave the 1 over cos squared alpha separate. So we have 16g all over 16g, happy days, 1 over cos squared alpha. That cancels out. So this has become a whole lot nicer. Except, what about the horrible trigonometry? Okay, so this is where we need to step aside into our log tables to figure out a few little bits and pieces. What we'll see is on page 13, the ones that I'm using anyway, we have a relationship here of tan alpha, which is sine alpha over cos alpha. So that's going to be really useful. We're going to switch everything to tans. Now, the next one is a little more subtle to find. We use the idea here of sec alpha. The secant of alpha is 1 over cos alpha. And if we look on the other side here, well, the secant squared of alpha is 1 plus tan squared. So what that does, in the end of the day, it gives us a little bit of information here. That's what we're going to use, which is that 1 over cos squared alpha is 1 plus tan squared alpha. All right, that's what we're going to use to solve this. Putting it all in, 2 equals 4 tan alpha minus, I'm going to use some brackets here, 1 plus tan squared alpha. At this stage we've got our quadratic. Now if you remember back in the beginning, we're looking for 2 possible values, so quadratic is exactly what we'd expect here. Okay, bit of housekeeping. 2 equals 4 tan alpha. This is where I love to make mistakes. Minus 1 minus tan squared alpha. Okay, rearrange them all, so I'm going to move all this stuff over to the left hand side. I'm going to end up with tan squared alpha, that's that guy over, minus 4 tan alpha, bring this guy over, and I end up with plus 3 equals 0. Now I have a quadratic to solve. And it might look ugly, but it's really just x squared minus 4x plus 3. So again, I wouldn't bother doing any kind of complicated stuff on this one. We have a tan alpha there, tan alpha there. I need 2 factors that are going to make 3. Obviously, the ones are 1 and 3 to look at, and they will make this nicely. So I have a 1 and a 3 combines to make a 4. So minus 4 minus 1 by minus 3 gives me plus 3. So that tells me that tan alpha equals 1 or 3. And we work that one out a little bit. We can see that alpha equals tan inverse of 1 or 3. I'm slightly off the page here. So alpha, this one is going to be 45. You might know that straight away, otherwise stick it into your calculator. And this one here is just a little messier. We'll bring up our calculator. So we have second function tan inverse 3, 71.565, so 57 degrees. And there's our answer.